Okay, now in this video we will discuss the next part, like we discussed in the previous part 1, part 2, part 3, modulus of z minus z1 minus modulus of z minus z2 equals to k. Now today modulus of z minus z1 plus modulus of z minus z2 equals to k. So what it represents? What is the locus of z? So this is again we will divide into cases. What is the value of k? So if I take k equals to, modulus of z1 minus z2, what happens? What is the locus of z that we have to know? Now see, if I take z1 and z2, 2 points, join these 2 points by a line. Now if I select a point z here, what happens? Like in the previous case, it satisfies the condition modulus of z minus z1 minus modulus of z minus z2 equals to k. That condition it satisfies, but here we have plus. So now if I select z is a point in between the points z1 and z2 and on the same line here, if I locate z here, so what happens? Now you see the distance between z and z1. The distance between z and z1 we can find using modulus of z minus z1. This is the distance between z and z1. Okay. Now the distance between z and z2 is this. The distance between z and z2. So I can say the distance between z and z1 is modulus of z minus z1. The distance between z and z2 is modulus of z minus z2. So if I add these two distances, one distance is this modulus of z minus z1, length of this z1 and this distance. If I add both the lengths, what happens? Obviously you will get the distance from the point z1 to the point z2. So what I mean to say is the distance z and z1 modulus of z minus z1 and the distance between z and z2 modulus of z minus z2, their addition gives what? The distance between z1 and z2. So that equals to modulus of z1 minus z2. So here if you take k equals to modulus of z1 minus z2, this k is replaced by modulus of z1 minus z2. So what happens? Then the point z, the variable point z is lies between the line segment or the line joining the points z1 and z2. So therefore in this case the locus of z is a line segment joining the points z1 comma z2. So therefore the conclusion is if k is equals to modulus of z1 minus z2, then the locus of z is a line segment joining z1 and z2. So next case, if k is not equals to modulus of z1 minus z2, what that z represents? So what is the locus of z if k is not equal to modulus of z1 minus z2? Like in the previous case, again, if k not equal to modulus of z1 minus z2, then z comma z1 and z2, they are non-collinear. They are non-collinear. So that means the points z1, z2 and z, they are not collinear, therefore they will form a triangle. Now once again, we know the basic property of triangle, that the sum of two sides, the length of the sum of two sides of a triangle is always more than the third side. So if I take the variable point z here, which is not collinear with the z1, z2, the distance between z and z1, this is the length denoted by modulus of z minus z1, and this is the length denoted by modulus of z minus z2, and this is the length denoted by modulus of Z1 minus Z2. So by the triangle inequality, the basic property of the triangle, what we can say that modulus of Z minus Z1 plus modulus of Z minus Z2 is greater than modulus of Z1 minus Z2. So by the triangle law. Now, modulus of Z minus Z1 plus modulus of Z minus Z2, I supposed that equals to K. So therefore, we can say that K is greater than modulus of Z1 minus Z2. Whenever K is not equal to modulus of Z1 minus Z2, that implies that K should be greater than modulus of Z1 minus Z2. Like in the previous case, if K less than modulus of Z1 minus Z2, what happens? If K is less than modulus of Z1 minus Z2, then there is no such Z exists. So the set, the empty set will be the locus of Z. There will be no such point whenever K is less than modulus of Z1 minus Z2. Now, if K is greater than or greater than modulus of Z1 minus Z2, what is the locus of Z? We have to know. Now, if we go into conic sections in ellipse, we have a property. The main property of the ellipse is the sum of focal distances is always fixed value. That is SP plus S dash P equals to 2A. So where this S and S dash are two fixed points. Actually, they are called foci. And P is a variable point which lies on the ellipse. So here we can see the same situation. If I say S of Z1, I take Z1 as S and S dash like Z2, and if I take P as a variable point Z, then what happens? Modulus of Z minus Z1, whatever here you are seeing modulus of Z minus Z1, that is nothing but the distance between S and P. So therefore it will become SP. Modulus of Z minus Z2, which is nothing but the distance between Z and Z2, that will become S dash P. And what we are saying here on property modulus of Z minus Z1 plus modulus of Z minus Z2 equals to K. So this is equals to K, where K is fixed value. So what is the meaning of this? Here the point Z1 and the point Z2, they are the foci, and the locus of P is the ellipse. So therefore, if modulus of Z minus Z1 plus modulus of Z minus Z2 equals to K with the condition K is greater than modulus of Z1 minus Z2, then the locus of Z will be the ellipse and S comma S dash will become the foci. Now we know the distances between the foci is 2AE. The distance between the foci is 2AE, that is distance between S and S dash, that is distance between Z1 and Z2, that equals to modulus of Z1 minus Z2, and here 2A will become K. So I'll take 2A equals to K. Therefore, eccentricity is equals to 2AE by 2A, that equals to modulus of Z1 minus Z2 by 2A is what now? Here K. So this is the same formula in the hyperbola also. E equals to modulus of Z1 minus Z2 divided by